Hello, Algebra and Honors Algebra students. Mr. Lawrence here with your first actual flipped lesson. I know I posted a POW help lesson or possibly uh, what was the other one? I can't even remember. Oh my gosh, I'm going crazy. Anyway, today we're going to be talking about the order of operations. Now, some of you might like to call it PEMDAS, but please don't ever do that again. Don't ever do that again. I know so many people, in fact, people that I graduated with, students, teachers that make the mistake. Yes, I know math teachers that make the mistake thinking multiplication always comes before division because of PEMDAS. So we're not going to use that word ever again. I can't believe I've said it so many times in this video. Stopped using it last year and the kids really liked it better. We're going to call it the order of operations. Now, it is true that the order of operations, we will begin by doing the parentheses first. Yeah, what's inside parentheses will take precedent. Now, there might be addition in there, or subtraction, or multiplication, or possibly an exponent, but we will definitely start inside the parentheses whenever possible. Sometimes there won't be anything to do in there, and then we'll move on out, but that's okay. We'll look inside the parentheses first. Now, next, we will, oh, excuse me, I'm going to sneeze. Achoo! We will look at the exponents next. And the exponents, are the powers when a number is raised to another number. And then we will look at the multiplication and division. We're going to look at them at the same time, and we're going to remember when we're on multiplication division, we're always going to work left to right. We work left to right. This is just the way the order of operations is done. Everybody around the world does it the same exact way so that we all get the same answer. Okay, sometimes people will try to make up their own way of doing it and they'll have trouble. So we're going to look at the parentheses, then we're going to look for exponents, and then when we're done with the parentheses and the exponents, we're going to consider multiplication division. We're always going to do whichever one comes first, working left to right. So in other words, multiplication does not have to come before division. No, if division appears first in the problem, we'll do the division first. All right. Uh-oh, another sneeze is coming on. Achoo! And we will then look at the addition and subtraction. And again, we're going to follow the rule of left to right. We're going to work left to right. Okay, so let's get down to the nitty-gritty. Here are the first two problems. They are order of operation problems. And I look at problem number one and I notice what types of operations are involved. Well, let's see here. I have some division going on, I have some multiplication going on, and I have some subtraction. Well, according to the order of operations, there are no parentheses, there are no exponents, and so I am going, can't tell if that's green, there we go. It looks blue to me. All right. uh, I'm going to work left to right. So my first step is going to be to do 40 divided by 4, which is 10. Bring down the rest of the problem like Bradley liked to say. And then I'm going to do 10 times 2 because multiplication comes before subtraction in the order of operations. This will get me 20 minus 3, and that'll be 17. And that problem is done correctly. I identified my operations, and then I followed the order of operations uh, to get the right answer. Okay, now over here on problem number 2, a very similar type problem. Let's see here. Looks like I have some multiplication right there. There's a division symbol there. Looks like I have subtraction and addition. And notice I did the multiplication division in the same color, and I did the addition and subtraction in the same color. Okay, now, before I actually do anything, I have to look inside my parentheses. And I have a couple set of parentheses. I have one set right here, but then I have these bracket things. That's like another set of parentheses. And they go from here all the way to here. Well, which one do we do first? Well, I start on the inside-most one. So I'm going to do this right here. So my problem becomes 7 times 8 minus the quantity of 20 minus 10 divided by, and I do this and get 5. Okay, now these parentheses are gone because I evaluated that to be 5, and then I close my bracket. Now, inside the parentheses, I have some subtraction and I have division. Well, according to the order of operations, I'm going to do the division first. So, buttons on your underwear. 7 times 8 minus the quantity of 20 minus 2. Okay. Still working inside the parentheses, I'm going to have 7 times 8 minus, and I'll have 18. There we go. Now, I have multiplication and I have subtraction. Multiplication comes first, so that'll be 56. 7 times 8 is 56, minus 18. Now, I like to work smart, not hard. I know off the top of my head that 56 minus 16 is 40. But I'm not taking 16 away, I'm taking 18 away. So that's like taking 2 more away, which would be 38. So this must equal 38. There you go. I don't want to subtract 18. I'd rather take away 16 because it makes my ones digits match, and then take 2 more away. I can do that in my head. Pretty simple stuff. Okay, problem number 3 is also order of operations, but I have to substitute numbers in. I want to caution you that whenever you substitute numbers in, you want to use parentheses whenever possible. So for problem A, I need t squared, so that's 9. So I'm going to go 9 squared minus the quantity s. Now, it may seem unnecessary in this problem, but if our s or t had been negative, it would be a very, very smart idea to use the parentheses. Minus 2. Now that I've used all my parentheses, or excuse me, I've done all my substitution, I will look inside this set of parentheses. There's nothing to do. Inside this set of parentheses, I essentially have 7 minus 2, which is 5. So this will become 5. And now I can do this exponent. 9 to the second power is 81. 81 minus 5, 76. Pretty easy stuff. Notice I'm doing this without a calculator. I expect you to be able to do most of these problems without a calculator as well. All right, problem B. 3 times the quantity of s, which is 7, plus t, which is 9, and then I'm going to divide by r squared. Well, there's 2 squared. So I'm going to start inside this quantity here and get 7 plus 9. So I'm going to have 3 times 16 divided by 2 squared. Now I'm going to do my exponent. 3 times 16 divided by 4. Now I have both multiplication and division. I'm going to work left to right. So 3 times 16 is 48 divided by 4. That'll equal 12, and there you go. All right, moving right along to evaluation type problems. Now, a lot of you are going to go 8 times 22 and 96 minus 92, figure out what that is, and then add 12 to it. I'm not going to do it that way. No, I like to work smart, not hard. I'm going to do this subtraction here first. That's going to be my first step. And that's, of course, is going to be 4. And I'm going to leave this as 8 times 22 plus 12. Now, I expect you to know that a fraction bar means divide. And I also expect you to know that multiplication and division are inverses of each other. which means they undo each other. And since they undo each other, I can think about 8 as the same thing as 4 times 2. So my numerator is like this. My numerator is like 4 times 2 times 22. That's over 4 plus 12. Now I'm going to show you why I'm doing this. Where's my shade? Shade. Okay. Whoop, where are you going? Okay. Hold on one second. This isn't working quite the way I wanted it to. Where's my eraser? Let me get that 4 back in there. There's the 4 in the denominator. If I do this, and I can see that 4 divided by 4 turns into 1, right? Well, now my numerator is a whole lot easier to deal with. I have 1 times 2 times 22, which is 44. The denominator is 1, so I don't need it. 44 plus 12 is 56. Yeah, you can do that. I know some of you are going, wait a minute, you made some kind of mistake there. No, watch. Watch what can happen with fractions. Let's say I had 16 times, I don't know, 25. And that was over, say, 40. Okay? Well, since the numerator is all multiplication, the denominator is just a number, and there's a fraction bar, division, I can cancel things out. I could think about my numerator as, say, 4 times 4 times 5 times 5. Now, this is a long way of doing it, but I'm doing it for the benefit of those that don't quite get it. Now, I could think of 40 as 4 times 5 times 2. And then one of those 4's could cancel with one of those 4's because 4 divided by 4 is 1. 5 could cancel with 5 because 5 divided by 5 is 1. And then I could also do this. 2 can go into 4 2 times because wouldn't 4 over 2 simplify to 2 over 1, or more plainly 2? So what happened is my entire denominator canceled out, leaving me with 2 times 5, or just plain old 10. Okay, now I don't do all that work. If I was doing it as a student, I would do this. I would say, well, let's see here. I know that 8 goes into both these numbers. 8 goes into 16 2 times, and 8 goes into 40 5 times. And I know that 5 goes into both 25 and 5. It goes in there once and goes in there 5 times. The numerator looks like this now, 2 times 5. The denominator looks like a 1. 2 times 5 is 10. Over 1 is the same as 10, and I get the same answer. This is why I get 10. This is how I would show my work because I don't want to break it down into everything. All right, so let's get back to the last problem. Sorry about that. Okay, same type of problem. I'm not going to do any, I can't cancel anything at the moment. Oh, did I write that down wrong? Oh, maybe not. Hold on one second. Let me pause the video. I don't like something. Okay, I think I'm ready to go with this. Now, I can't do any canceling yet because there's addition in the numerator, and division cannot undo addition. So I have to add in the numerator first. And I believe when I add, I'm going to get 117. Now, the denominator, I'm going to have 31 times 3. Well, I'm not going to multiply these and then simplify because I know that 1 plus 1 plus 7 equals 9. And that means that 3 and 9 both go into 117. That trick only works for 3 or 9s. If you add up the digits and get a multiple of 3, then 3 goes into the number. If you add up the digits and get a multiple of 9, then 9 goes into the number. So what I have here, I know I can simplify 117 over 3. I'm not sure what it's going to simplify to because I don't know that off the top of my head. But if I do a little bit of division here real quick, I know that's going to go in 3. Looks like it's going to go 39 times. Yeah, I think that'll be right. Okay, so I'm going to say 3 goes into 3 once. It goes into 117 39 times. Now, I don't believe I have a common factor between 39 and 31 because 31 is a prime number. So I'm going to have 39 31st. Now, you may have been told in elementary school that you never give an improper fraction, and I want to tell you that's not true. Okay, in algebra, sometimes it is smarter to give an improper fraction. Sometimes it's smarter to give a decimal, and sometimes it's smarter to give a mixed number. So if you gave this to me as an answer, I would accept it for full credit. Now, if you wanted to, you could turn it into a mixed number and say 31 goes in 39 one time. It's 8 short, so it would be 1 and 8. And I divided by 31, so 1 and 8 31st. I don't know about you, but these seem the same thing to me. I probably wouldn't go decimal on this because 8 31st is going to be an ugly decimal. I have to round it, and that's going to affect my accuracy. All right, Mr. Lawrence is going to sign off now. Thanks for watching the first video. Good night, everybody.